Hi guys, here's the video that goes over our notes for section 5.7 applied problems. So what we're doing with this particular section is going back to solving right triangles. So we're going to solve regular right triangles, special right triangles, and use them to solve some application problems. So when I say solve a right triangle, that means you're solving for all missing sides and all missing angles. The sides we can go ahead and round to the nearest tenth, and the angles we can go ahead and round to the nearest hundredth. So the triangles that you're going off of is this right here. So we have angle A, B, and C. We label that with alpha, beta, and gamma. So there's alpha. Alpha is angle A. Beta is angle B, and gamma is angle C. Across from alpha is side A, across from beta is side B, and across from gamma is side C. So we're going to use that triangle to solve for all of those missing pieces. So let's go ahead and draw our triangle first for letter A. So I know that gamma is 90 degrees, so that's 90 degrees. I also know that alpha is 30 degrees. Alpha is the angle at the top. And I know side C is 10. So the things that I'm missing side A, side B, and angle beta. Now this is a 30, 60, 90 triangle, so we're going back to our special right triangles. So along the side over here, I'm going to draw our special right triangles because it's been a while since we've done them. So if this is 60 degrees, across from 60 degrees is the square root of 3 times x. Across from the 30 degrees is x, and across from the 90 degrees is 2x. For the 45, 45, 90s, there's 45 degrees, 45 degrees, that's x, x, and root 2x. So now that I know that it's a 30, 60, 90 triangle, I can go ahead and label the sides accordingly. So across from the 30 degrees is x. Now we do know that beta is 60 degrees, since alpha is 30 degrees, because it has to add up to 180 degrees. So across from beta is root 3 times x, and your hypotenuse is 2x. So since my hypotenuse is 10, and 10 is equivalent to the 2x, I can use that to solve for x, which in turn will allow us to solve for the two missing sides. So x equals 5, a is equal to x, so that means side A is 5, and b is equal to the square root of 3 times x, so that would be 5 root 3. And there's your answer for letter A. Letter B I'm actually going to skip because if you'll notice, you see that A is 5, B is 5 root 3, and beta is 60. So then that's the same thing as the triangle for letter A. So I was not paying extra close attention when I was making that example, apparently. For letter C, I can go ahead and draw my triangle. So my gamma is 90 degrees. Side A is 13. Side B is also 13. So I'm missing alpha and beta. But if you'll notice, that is an isosceles triangle, and out of those two triangles for our special right triangles, the one that's isosceles is your 45, 45, 90. So I know that alpha has to be 45 degrees. Beta also has to be 45 degrees. And using what we know about right triangles, this is x, x, square root of 2 times x, which is side C, which we're missing. So since x is 13, that means side C is 13 root 2. I think I said square root of 3 when I wrote that down, but I meant square root of 2. Or maybe I said square root of 2. I don't know. It's getting late. Alright, so when I give you any angles that's 30, 60, 60, or 45, you're going to use the special right triangles to find the exact values. Now let's say I use angles that are not special, And what are we going to do with that? So if I give you an angle that's not special, like 30, 60, or 45, we resort back to good old SOHCAHTOA to solve the triangle. So let's look at letter A. Gamma is 90 degrees. Beta is 42 degrees, 35 minutes. We don't know what alpha is, but we do know side A is 26. We don't know side B, and we don't know side C. So since I do have two of the angles, I can go ahead and solve for alpha. Since I know that the angles in a triangle add up to 190. I also know that since your right angle is 90 degrees, alpha and beta have to add up to 90 degrees. So I'm taking 90 minus the 42 degrees, 35 minutes. So that gives me, let's change to degrees and minutes. That gives me 47 degrees, 25 minutes. Now since my original angle measurement was in degrees and minutes, your other angle measurements also need to be in degrees and minutes, so just try to stay consistent with that. Now to find your sides, I'm going to go ahead and start by picking a side. I'm going to start by solving for side B, and I'm going to use the information that was given to me. So I have this angle, and I have this side. So I need to see how B and the 26 relate to that angle. Side B is your opposite, and then the 26 is your adjacent. And then from there, using SOHCAHTOA, you figure out which trig ratio you're going to use. So that's going to be tangent, because I have opposite and adjacent. So I have tangent of 42 degrees, 35 minutes, equals my opposite side, which is B, over 26. Since my B is on top, I can go ahead and multiply the two. So that's 26 tangent of 42 degrees, 35 minutes. And using my calculator, 26 tangent of 42 degrees, 25 or 35 minutes. Oh, my calculator's in the wrong mode. Make sure your calculator is in degree mode since you're working with degrees. Let's try that again. Okay, so that gives me 23.9. So that means side B is 23.9. So I have my alpha, I have side B, and the only thing that I'm missing is side C, but since I now know that B is 23.9, I can use the Pythagorean theorem to solve for side C. So it's a square root of A squared plus B squared. So square root of 26 plus 23.9 squared gives you 35.3. So now I have all three sides and all three angles. For letter B, I'm going to go ahead and draw my triangle. Gamma is 90 degrees. I don't know alpha. I do not know beta, but I do know side A and side C. Oh, I labeled that wrong. Side C is the hypotenuse. Oh, I should actually use the number. So side C is 20, so I'm going to put 20 in for side C, and I'm missing side B. I can easily solve for side B by using the Pythagorean theorem. So it's a square root of 20 squared minus 14 squared. Sides again, we'll go ahead and round to the nearest tenth. That gives us 14.3. Okay, so now I need to pick an angle to solve for. I'm going to go ahead and solve for angle alpha. I'm going to use what was given to me. So the side that's labeled 14, that's the opposite. And the side that is across from your hypotenuse, or your right angle, is your hypotenuse. So I'm using opposite and hypotenuse, so that's going to be sine, because sine uses opposite and hypotenuse. So I have sine of alpha equals 14 over 20. Since I'm solving for an angle, I'm going to do the inverse. So the inverse sine of 14 over 20. So inverse sine of 14 over 20. Angles again will round to the nearest degree, so this one is 44 degrees. So I now know that alpha is 44 degrees, and then using the fact that your alpha and beta have to add up to 90, since it is a right triangle, that makes beta 46 degrees. All right. For the applications on the back of your notes, I'm only going to do the first one. With the other ones, we're just drawing pictures and then setting up your angles accurately, or your triangles accurately, and using what we know about SOHCAHTOA to be able to solve. So for the first one, we have two buildings that are 250 feet apart. So I'm going to go ahead and start by drawing my two buildings. It's always helpful to have a visual. So here's building number 1 and building number 2. A surveyor standing on top of the building, which is 300 feet tall, measures the angle of depression to the top of the other building as 15 degrees 45 minutes. So the angle of depression is from the horizontal and down. So since we're dealing with the angle of depression, that means our surveyor is standing on top of the taller building and looking down. So there he is, standing on top and looking down at the other building. That right there is your angle of depression, which is 15 degrees 45 minutes. Now what we're trying to find, our big mystery for this problem, is the height of the second building. So this is what we're trying to find. We do know the height of the first building is 300 feet. But we don't know what the height of the second building is. We also know that the buildings are 250 feet apart. So this distance is 250 feet. And if you look, we got ourselves a nice right triangle. So if I know the height of this first building is 300 feet, I can figure out what this is, the difference between the heights, and then just subtract them, and then that would give me the height of the second building. So using our right triangle, we have this angle and these two sides. We want to see how those two sides relate to that given angle. So your x is your opposite, your 250 is your adjacent. So opposite and adjacent means I'm using tangent. So I'm doing tangent of 15 degrees 45 minutes equals opposite over adjacent. Since your x is on top, I can go ahead and multiply, so that's 250 tangent of 15 degrees 45 minutes. Using my calculator, 250 tangent 15 degrees 45 minutes. That gives me 70.5 feet. So that means the first building is 70.5 feet taller than the second building. So if I'm trying to figure out the actual height of the second building, I'm taking 300 minus 70.5, which gives you 229.5 feet. And that is the height of the other building. Alright, so that is the video that goes over your notes for today. Again, the other two application problems you can go ahead and try on your own. But yeah, I hope this helps.